I'm extremely honored to be here today to show the inspiration actually through Stan's publication to especially on the area I'm working on, spatial temporal data mining. So I'm trying to show my understanding of geocomputation with spatial temporal data mining and try to give a very brief review on the development and the challenges in STDM, which is followed by some efforts have been made to tackle those challenges, and finished by proposing my view on the future direction in spatial temporal data mining and geocomputation. So, although there are many definitions of geocomputation, if I take the latest one in the book, I think it combines three things. The first bit is geo, so it including the problem in geographical or environmental problem, and actually beyond that, such as economic or engineering problem. And the second bit is the computation, which have two things. One is the theory or technology or algorithm, and that's hardware, that's software. The third bit is the one Poloni just mentioned about HPC, which I think is infrastructure and hardware, which I'm not going to talk. So I want to focus on the second bit, the technology and algorithm, which including several things. One is conventional statistical mathematical approach, or we call it smart machine learning, and also including Mike's work on simulation. Of course, now we've got agent-based simulation more. At that time, when Stan talked about that, Stan said, yeah, we'll now actually try to understand the phenomena, the problem. But now we actually moved to talk more on the dynamic part. So we should think about the temporal aspect. And Stan also mentioned that now we've got more data. We should really move to data mining, but much haven't done yet. So actually, it's these two things: move to process, move to data-rich environment. We got spatial temporal data mining. Of course, you also got lots of definition of spatial temporal data mining, but we can summarize them in 5 things. If you look at them in detail, actually, you may say nothing very not new, except we extended from spatial to spatial temporal. So from spatial modeling, we move to spatial temporal forecasting and prediction. And from spatial analysis, we move to, spatial temporal association rule mining, which has been shown in core locational analysis. And maybe the special one is the spatial temporal sequential pattern mining, which is really emphasized on the temporal thing. Of course, we have spatial classification, clustering, and visualization. We put one more dimension there. So, seems not much new, but of course, since the complexity of spatial is complicated enough, but of course, with temporal dimension, we have more challenges. So I think that my view is the main challenge nice in this is the non-stationarity, which has been talked a lot already as a scale issue. There are 2 approaches, statistical approach and the machine learning approach. For statistical approach, I think, how are we able to calibrate the autocorrelation? So either we accommodate it in the modeling approach, or either we fill them out. For machine learning approach, it's a nice way to do it, but how we increase the interpretability of it. There are all the challenges. For clustering, clustering has been used a lot for finding the outliers, but we put in the temporal dimension has been used for detecting the outliers or emerging phenomena, which has been used for epidemic studies, which Stan has been working on that. So the challenge would be to see how we can put in the all dimensions together, and most importantly, how we can model the dynamics in the data is still quite difficult. Spatial temporal scan statistics has shown some light on that, but when you look at it, spatial temporal scan statistic actually come from spatial scan statistic, but the spatial scan statistic actually come from GAN, so which Chris already mentioned today. So we can say the inference was done here. But of course, how are we going to improve the efficiency of computation, how to reduce false alarm rate is still something difficult. Now move to visualization. So for visualization, we already started from statistical 2D dimension to 3D. We have a lot of tools, but real-time visualization to see the process, especially the evolution and the separation of the process, is it's still lack of tools to do it. So I'm saying that, so I'm trying to show you, say, combine this all together, dynamics, heterogeneity in an example of transport study through our recent project I'm leading on. This is working with Transport for London. So for that, we're trying to make journey time prediction, short time, long time, and trying to do early detection of traffic congestion. And we also want to provide tools to do for traffic manager to interactively visualize the journey time reliability. Actually, it's a major task for TfL, for Olympic Games. And we also want to provide tools to simulate non-recurrent congestion. So if we start from Google, I'm sure you must be used to it. Google are able to show you what happened in the past and what's the real-time situation in transport, in traffic. So what do we do? So we're trying to look ahead. Can we make a prediction based on the historical data and the real-time data to look ahead? What happened 5 minutes, 50 minutes, half an hour? So as I said, the challenge is the dynamics and the locability because heterogeneity there. So we propose a model which is able to consider about the spatial with the metrics to accommodate in these two things. So what we've done is trying to produce a model which is able to accommodate in these two things. That's the result trying to show you. That's what we call localized ST-RIMA model. ST-RIMA is a global model, but for considering the locability and also the dynamics, we're able to improve the accuracy of prediction. So another thing, say, trying to get the understand the traffic, emerging traffic congestion. So we use spatial temporal scan statistics, trying to understand where the traffic most significant event happening on the network. This is just one example showing that today, you can see the traffic really built up on actually starting from this road and then it's happening around it. Yeah, you can see major traffic congestion is happening this road and moving around that region. You can see that. Actually, that day, the incident happened there. You can see it accumulated at the time and then disappeared later on, but it is constantly congested in that area. Now move to visualization. I really think it's a visualization. We've got lots of data. We're able to visualize them very nicely, but what can we say from the data to process actually really see some story about it. This is nothing new. This is snapshot of, say, a hotspot area and the ratio of the congestion. So now we want to tell the story. This is data to show you the influence of tube strike in London on 6th and 7th last year. The tube strike happened at 6 p.m. on 6th and finished at 6 p.m. on 7th. You can see these 2 days, the situation was very different. This is a very static view, but if we show more about it, you can say the similar. They're different. The extension and the duration and the severity is very different for these 2 days. So, but we want to say it more interactive way. So the scale is a big issue. So we want to provide a tool able to show the dynamics at different temporal scale. So we provide interactive tools to do it. Let's just give a very brief example. So this is produced by processing. Really say we can use this animation. You can really say how the traffic is built up. This is just show you one typical day, started from middle light to 12 o'clock in the middle of the day. So it started very smoothly and then accumulated gradually. 4, 6 o'clock started. London started transport congestion very early until continuously congested middle of the day. So you can rotate it actually. We can also show them individual profile, different things. Okay, move on. This is another example. I said nowadays we're able to use agent-based simulation to understand very detailed situation on the network. So this is really show you part of London, and we use 3,000 drivers running around on the network with different origin and destination, and they have all different behavior. Means they have different knowledge, and they have different preference of the route choice, and they know differently about network, and some are patient to wait longer, some are less patient to wait queue on the line. So you can see the traffic started accumulated. The green shows is very smooth, less congested. Yellow and red means getting more and more congested. So you can see is getting more congestion at different areas. So what's the purpose for that? Basically, this can help you say if something happened and one of link, how people respond to it, how they change their behavior. So they can really help the traffic manager to understand what they're going to change in terms of level of performance. Okay, last bit is we really want to understand how people move around in space and time. But nowadays, we use GPS a lot in different forms, mobile phones, iPhone smartphones. So what do we do? This is showing you the GPS dot. And then we move to see how we can understand hybrid mode of transport. We use machine learning approach. Okay, so this is basically, you can see this area is really UCL. This is only able to show 21 because we use the resolution of the image. So you can see most people based in UCL, so that's where the square comes off. And we're getting running on anyhow. So just say that will give you some, I hope they give you a flavor, say what are we doing here, trying to tackle those challenge. If we look ahead, I think we really needed to understand how we can able to mine those crowd source and make and trying to combine with text mining, so make a sense, really make a sense of the data. And importantly, we needed to link those individual sensor to under the framework of network to really understand the interaction and the flow of the data. When we talk about community, we have to really understand what the ready data means. And one more thing is, we're talking about mining the patterns, but important is can we really find out the critical points. That means we're able to avoid the worst scenarios. And the last bit, actually, Poloni also mentioned about, say, we have lots of funding, but how we're able to calibrate and validate all of them. I think it's a big issue. Nowadays, it's nice, you got some data out of your, got patterns of data, but what's really meaningful that. Of course, this has been talked. I'm not going to talk about that, but I will just put one more thing. It's a systematic application. So there's another example we're going to work on is really to use crime, police, and citizenship. We try to understand the relationship of the movement of policemen with crime and people's perception. So that's the way we want to move forward. That's going to be launched very shortly. Last thing is we're going to say what's the influence of geocomputation. I've been in Europe, but the next one will be going to hold in China, in Wuhan. So we believe more people join this community, this subject will be more alive. Yes. Thank you so much for coming here.